So in the last video we saw how to use recursion to solve the anagram problem, wherein we took a string and we took all the different permutations of the characters that are there in the string. We did it in the Java programming language. So in today's video what we will do is we will see the same program being implemented in Python and see how recursion is being used to do the same algorithm, right? So let's get quickly started. So here I've created a new file called anagram.py. Now let's start with the function which will be called permute. Now let's come to the set of parameters that has to go inside in a short while. Now what we need to do is to find out, given a string ABC, all the permutations of the characters A, B and C should be given as output. Now they are ABC, ACB, BAC, BCA, CAB, CBA. Right? Now there are three characters in the string ABC, so the number of permutations will be 3 factorial, which is nothing but 6, which is what we see here. Right? So let's go about writing the program which takes ABC as input and gives these different anagrams as output. So from this example, what we are able to see is there must be two different parameters that are to be passed in. One is the original string, which will provide all the characters to be used to build the anagrams. The second is the set of each one of these anagrams which are getting created as and when we run through the loops, right? So we need to have at least two parameters to be passed to this function. Now for simplicity, let us call the anagram which is getting generated as str and the remaining characters which will be provided by the original string as remaining, right? So with these two inputs, let's start writing. Now what we need to do is, first we need to get the characters from the original string. The original string in this case is remaining, right? It's referred by remaining. So what you'll say is for C in remaining for each character that is there in remaining, I need to create a new string, new str, which is nothing but the anagram which I am forming. So new str initially will start with nothing, so which is what str is also having right now. So str is having nothing and I want to add the C which I am getting from remaining, right? So I am forming my anagram or the first permutation for the first time, starting with the letters, the character which is represented by C. Now that I have taken one character from remaining, I need to subtract it from remaining, right? So what I will do in Python is I need to find out the index of this character C in remaining, get the substring which goes still from 0 to this particular index, ignore this particular the character which is there in this index, and then get the remaining substrings which are there after the index, right? So what we will first do is index equal to remaining dot index of the character C. We got the index. Now what we need is to find the substring. So we will say new remaining equal to remaining from 0 to index. We are using the slicing operation in Python to get this done. Nothing plus remaining from index plus 1 location till the end of the string. So we got the new remaining as well. Now all we need to do is just call permute again, but this time we will be passing the new string and the new remaining, so that the next iteration has only whatever is left behind after computing, right? Now as usual we need to have an exit condition for this recursive loop. So what we can do is the exit condition for in this case is whenever there is no other character remaining in this particular attribute, in this parameter called remaining. So which means that all the characters have been transferred to form one of these words which is represented by str. So what we will do is if remaining is empty, then print str, right? Great. So our definition, our method is completed, function is completed. Now let's invoke this from our main method. permute. Initially your anagrams are going to be empty, so I'm just passing an empty string, and we'll be passing say ABC. That's what we want to check. So you go here and say let's see the output. So here it's come and created all the different permutations of the string that we just gave, is ABC, which is exactly what we wanted, 6 different words. Now what we'll do is, we'll try to make this a little bit more practical. So all the characters in this particular string are non-repeating, so let's make it repeating. If we make this and see how the program responds, we see all the permutations getting generated, but we're also seeing that there are duplicates getting generated here, because the character B is repeating twice. So one of the B's is different from other B, and the program doesn't know how to differentiate them, right? So we have 2 ABBs, we have got 2 BABs, we have got 2 BBAs. Now let's try to modify this code to print only unique values or unique anagrams that are going to get generated, which means I need to have only one ABB, one BAB and one BBA, right? Now how do we do that? So for this we are going to use the set data structure to accomplish this. A set data structure by definition has a property that it can store only unique values in it. So we are going to use that particular property of set to get our thing done. So to do that, what we'll do is we'll create a variable for holding the particular unique values. We'll call it final set, and we'll initiate it with the set constructor. Then what we'll do is we'll pass it on to this permute function. Since we're passing it here, we also have to pass it to the definition final set. Great. Now that we have a set which is going to collect all the results, instead of printing it, what we'll do is we'll say final set dot add str. Great. And here final set is again to be called because we want the collected items to be passed on to the next iteration of permute, so that everything gets accumulated towards the end of all these loops and finally gets passed on to main. Now that the permute function has been modified, we need to print it in the main function. What we'll do is we'll say for s in final set print s. Right? Now let's quickly try to run this and see how it works. Great. Now we see that only unique values are getting printed, right? Now let's try to put a breakpoint to see how it actually works, how the set actually makes sure that you don't add anything else, anything new to any duplicates, right? So we'll go to run, start debugging. Right? I'll put one more breakpoint here just to make sure that we get it. So we go into permute, and of course you've already seen how the recursive loops operate. You've already seen how the call stack keeps track of all the calls that are being made again and again by the recursive function. So we're not going to go back into this. So what I'm going to do is I'm quickly going to press F5 so that we will have the first word which is ready to be added to this set. So here we are. The first word that is getting generated is ABB. Right now final set is empty, so we are going to add the first candidate into this list. Great. Now let's run this again for the entire loop. I'm going to press F5 to do the entire operation. Again we have ABB coming in, and we are going to be adding it into the set. Now let's see, if I press the next statement, final set did not add the new one. It did not add the duplicate ABB into the set, right? And due to this, we get only unique values. I'm pressing F5 again. This time we are going to add BAB. It is not there, so BAB gets added. We are again getting BBA. BBA is not there, so BBA got added. BAB is already again coming in, but BAB is already there, it did not get added. BBA is again coming in, and it closes. And that's how we get this. So thank you all. I hope you had gotten a decent understanding of using recursion to solve this particular problem of finding anagrams or permutations of the characters in a string. It's a very simple example. We just tried to make it more practical by introducing the set into the picture so that you will only get unique values in case there are repeatable characters in your string. As usual, if you have any queries, please put them in the comments. I'll be more than happy to discuss, or you can have another video just to explain the same. Thank you very much for watching.